So this is a preliminary paper on the proposed age of Beta Pictoris b. It's a evolved star that's orbiting Beta Pictoris. I have here Beta Pictoris b is proposed to be about 250 million years old according to its total axial angular momentum with reference to the general theory. Now, where I'm going with this is I sincerely believe that axial angular momentum, like a basketball spinning on your finger, can tell us a whole hell of a lot more about stars as they evolve into life-hosting stars such as the Earth, stellar remains. And this is really important because when you go to Wikipedia, when you go to these mainstream articles, they never mention anything like that. They don't talk about how the planets actually spin, why they're spinning to begin with. And it's a very big problem. Why should the Earth spin with the same angular velocity or similar angular velocity as Mars? And why is Jupiter and Saturn, why are they spinning faster, even though they're much more massive? You would think if they all came from one giant spinning disk around the sun, as is accepted and taught by the dogmatists, that Jupiter and Saturn's angular velocity would be a lot lower than the Earth because there's more mass there. But yet they spin faster, like the whole thing spins around faster. How is that? Why is that? And clearly what that's telling us is that Jupiter and Saturn are less evolved. They have a lot more energy there because they were much more massive at one point. And anyways, it's very important to see what astronomers are missing. And the way you do that now with this theory is to connect the objects that are highly evolved, such as the Earth, with objects like Neptune, Uranus, or the Sun, and you draw connections with them everywhere you go. And with this, I printed out this from another page, and then I scanned it again, and I reprinted it to attach it to this form. The basics for this theory are you don't have separation between concepts. The astronomers, they've separated star from planet. So every single model they draw up, every single theory they draw up, every single idea they draw up has star as a closed system. And then there's a big impasse in between star, and then you have brown dwarf, and then those are closed systems. And then you have another impasse, and then you have planet, which is also a closed system. And if I can stress to my readers or listeners I can't stress this enough, the way to look at these objects is being on a continuum with every single physical parameter that is available to us by observation, observing the physical parameters and then making the connections with the objects that are observed. I mean, it's that simple. Don't take your mind and don't take what the astronomer is saying is true and use their mentality by not making connections and forcing them to be independent. Use your mind and realize that they are one and the same and that they can be connected on a longer line of evolution. Similar to us and all the organisms on the Earth. That's what Darwin did. The natural selection that we're related to all the life on the Earth, and all life is related to all other life, and that there's a much larger unseen connection between them, the theory of evolution. And it's very important because you have to take that kind of mentality, the unseen time variable, and apply the time variable to a lot of the connections we're making too. And it takes time for stars that are spinning with a lot of angular momentum, they're huge. It takes time for them to slow down because when they're interacting with a vacuum, there's essentially no friction. I mean, sure, you have a little bit of magnetic friction you have a little bit of atmospheric friction, and you have mass loss, but the rate at which they slow down their spin is very, very, very slow at the beginning, and then it just slows down even more as they evolve. So I have the sun up here, and this has a lot of angular momentum, and it's really, really young. But as it evolves, now this is not the Walensky-Taylor diagram. This is axial angular momentum diagram. This is one of the first axial angular momentum diagrams, as we're probably going to be working on this a lot more because the field of gyrochronology simply doesn't even exist yet. When you go to Wikipedia and look up gyrochronology, they don't even make the connection of stars evolving into rocky objects such as the Earth. It doesn't exist. We're making a new field of science exist right now. And that's why I want to put a lot of pressure on this approach. And this is why it's very important, because there's a lot of information to be gathered. And now that we can actually measure the spin rates of literal stars, evolving stars around other stars in other solar systems and other star systems, this field is going to massively blow up. And we're literally the first people on the planet to be doing this. It's pretty surreal. But anyways, you have the sun here, very young. And as it loses mass, it in turn will also lose its angular momentum. And because both mass and angular momentum are conserved quantities, when you lose mass, obviously you lose your total axial angular momentum as well. It's like taking the mass away from a basketball when it's I don't know how you would do that. Maybe take the air out of it. I don't know, but then it would spin with less energy. Now, Jupiter is about right there. Saturn's about right there. Now you see how it curves? Now this is also a log scale, so remember that. See how it curves right there? I'm gonna have to find a math formula to figure that out and do some calculus to do a tangent on this curve. The instantaneous rate of change at a specific point. I remember doing calculus back in Florida State. I have to brush up on it a little bit. I've been staying away from the math for now because the basic concepts are what's important. And then it kind of like levels out around what would that be? Neptune and Uranus, which are very, very close to each other in age and total axial angular momentum. And then it starts curving down again considerably to Venus, to where the total axial angular momentum is almost nothing in comparison to Neptune, Uranus, Earth, or even Mars. Even though Venus has more mass than Mars, Venus is just rotating so slowly, it's almost completely gone. Sure, it's still a lot of axial angular momentum, but relative to the other objects, it's very, very, very dead. Venus is just a dead world. And then I don't even have Mercury on here. Mercury is just beyond dead. This trillions and trillions of years old. I have another paper. And I don't want to read this paper. I just want you guys to read it for yourself. I'm being a little mean in this paper, but it helps for me to vent a little bit, because it's so easy to look at this stuff. And also have a calculation here. I use the multiplier for Jupiter because it's in Jupiter masses, so I just put 12.9. Beta Pictoris B is 12.9 Jupiter masses, and that's Jupiter's mass. And it's also 1.46 Jupiter radii. And that means its total axial angular momentum is 3.48 times 10 to the 40 kilogram meter squared seconds to seconds. And as well, I'm not too sure how I'm going to write. I think I'm going to make axial angular momentum a dimensionless quantity, meaning you take the kilograms away, you take the meters away, you take the seconds away and you just make it a single number, I think that would be helpful for writing everything down so you can make things more smooth. It's like a dimensionless number, like the Reynolds number when it comes to viscous flow. But I'm not too sure if I want to make it a dimensionless number yet. But I mean, if I do, the reason why I want to is because the exponents are so large. When I have the paper, you'll see in the paper, I have the top, where's that at? I have the top angular momentum up here as, being 1 over here, and then 100 and 1,000, and Earth has about 1,000. 1,000 what? But I removed about 31 zeros to make it dimensionless. 31 zeros. That's a lot. That's a lot of material. It's a lot of energy being removed to make it dimensionless. But anyways, like I said, I'm gonna figure out some calculus and try to hone this graph a little bit, because if we can take the spin rates of stars and how much axial angular momentum they have and figure out how old they are from that alone, that would be surreal. But I don't think it's going to be that simple, because you also have ZH ratios, you also have tidal interactions, you also have rate of mass loss, different rates of mass loss. It's a multiple variable thing when it comes to figuring out how old these objects are. But one thing's for sure, gyrochronology, this is the first time it's ever really existed in the form that it should exist in. All right, you guys, take it easy.